Hello, today we are going to talk about arithmetic sequences and the geometric sequences. The definition of arithmetic sequences, let's look at the sequence 6, 10, 14, and 18. Obviously, the difference between each terms is equal to 4, and the sequences can be written as a n sub n plus 1 is equal to a sub n plus 4, where a sub 1 is equal to 6. For the sequences 23 and 21, 29. The formula will be a sub n plus 1 is equal to a sub n minus 2, where a sub 1 is equal to 23. In this example, the difference between consecutive terms in each sequence is the same. We call sequence with the special property arithmetic sequences if d is positive, we say arithmetic sequences is increasing, and if d is negative, we say the arithmetic sequences is decreasing. First example, state whether the following sequences are arithmetic or not. If a sequence is arithmetic, find the common difference. First, 7, 10, 13, 16. Solution. This arithmetic, and d is equal to 3. Second, 3 minus 2 minus 7 minus 12. Solution. This is arithmetic, and d is equal to minus 5. Third, 1, 4, 9, 16. Solution. This is not arithmetic. And the fourth, 6, 6, 6, 6. Solution. This arithmetic sequence, and d is equal to 0. 7, 10, 13, 16. If we develop ourselves by 3% per day, we will get great results in the end. And 6, 6, 6, 6, and if we take d as an effort, if we will not develop at all and remain the same. That's why development is important. General term, since arithmetic sequence have many applications, it is much better to express the general term directly instead of recursively. The formula is derived as follows: if a sub n is arithmetic, and then we only know that a sub n plus 1 is equal to a sub n plus d. Let us write a few terms. A sub 1 is equal to a sub 1, and a sub 2 is equal to a sub 1 plus d, and a sub 3 is equal to a sub 2 plus d is equal to a sub 1 plus d is equal to a sub 1 plus 2d. A sub 4 is equal to a sub 3 plus d is equal to a sub 1 plus 2d plus d is equal to a sub 1 plus 3d. And a plus a sub 5 is equal to a sub 1 plus 4 times d. And a sub n is equal to a sub 1 plus n minus 1 times d. This is a general term of arithmetic sequences. Second example, minus 3, 2, 7 are the first three terms of an arithmetic sequences. Find the 20th term. Solution. We know that a sub 1 is equal to minus 3 and the d is equal to a sub 3 minus a sub 2 is equal to a sub 2 minus a sub 1 is equal to 5. Using the general term formula, a sub n is equal to a sub 1 plus n minus 1 times d. And a sub 20 is equal to minus 3 plus 20 minus 1 times 5 is equal to 92. A sum of the terms of arithmetic sequences. Let us consider an arithmetic sequences whose first few terms are 3, 7, 11, 15, 19. The sum of the first term of this sequence is obviously 3. The sum of the first two terms is 10. The sum of the first term of first three terms is 21, and so on, To write this in a more formal way, let us use S sub n to denote the sum of the first n terms. S sub n is equal to a sub 1 plus a sub 2 plus sum of a plus a sub n. Now we can write S sub 1 is equal to 3 and S sub 2 is equal to 3 plus 7 is equal to 10. S sub 3 is equal to 3 plus 7 plus 11 is equal to 21. And S sub 4 is equal to 3 plus 7 plus 11 plus 15 is equal to 36. S sub 5 is equal to 3 plus 7 plus 11 plus 15 plus 19 is equal to 55. Third example, given the arithmetic sequence with general form a sub n is equal to 3n plus 1, find the sum of first three terms. Solution S sub 3 is equal to a plus a sub 1 plus a sub 2 plus a sub 3 is equal to 4 plus 7 plus 10 is equal to 21. How could we find 10 sub 100 in the above example? Calculating terms and finding their sums takes time and effort for a large sum, since arithmetic sequences are of special interest and importance. We need a more efficient way of calculating the sum of arithmetic sequences. The following theorem proves this. The sum of the first terms of an arithmetic sequences is s sub n is equal to a sub 1 plus a sub n over 2 times n. And the s sub n is equal to a sub 1 plus a sub 2 plus a n sub n minus 1 plus a sub n. S sub n is equal to a sub n plus n a sub n minus 1 plus sum of a sub 2 plus a sub 1. Adding these equations side by side, 2 times s sub n is equal to a sub 1 plus a sub n plus a sub 2 plus a sub n minus 1 plus sum of a sub n minus 1 plus a sub 2 plus a sub n plus a sub 1, and the s sub n is equal to a sub 1 plus a sub n plus a sub 1 plus d plus a sub n minus d plus a sub n minus d plus a sub 1 plus d plus a sub n plus a sub 1. Next, 2 times s sub n is equal to a sub 1 plus a sub n plus a sub 1 plus a sub n plus a sub 1 plus a sub n plus a sub 1 plus a sub n. This is n times, and 2 times s sub n is equal to a sub 1 plus a sub n times n. And next, s sub n is equal to a sub 1 plus a sub n over 2 times n. Geometric sequences. If a sequence b sub n has the same ratio q between consecutive terms, then it is called a geometric sequence. In other words, b sub n is geometric sequences if b sub n plus 1 is equal to b sub n times q, such that n belongs to natural number and q belongs to real number. Q is called the common ratio of the sequences. First, if Q more than 1, the geometric sequences is increasing when B sub 1 more than 0, and decreasing when B sub 1 less than 0. And the second, this first, second, if 0 less than Q less than 1, geometric sequence is increasing when B sub 1 less than 0, decreasing when B sub 1 more than 0. Third, if Q less than 0, then the sequence is not monotone. First example, state whether the following sequences are geometric or not. If sequence is geometric, find the common ratio. First, 1, 2, 4, 8. Solution, this geometric, and the Q is equal to 2. 3, 3, 3, 3. Solution, this geometric, and Q is equal to 1. Third, 1, 4, 9, 16. Solution, this not geometric. And the fourth, 5 minus 1, 1 over 5, minus 1 over 25. Solution, this is geometric, and Q is equal to minus 1 over 5. General term, we have seen that for geometric sequence, B sub n plus 1 is equal to B sub n times Q. This formula is defined recursively, and if we want to make faster calculations, we need to express the general term of a geometric sequence more directly. The formula is derived as follows. If the geometric sequence, then we only know that if it's geometric sequence, then we only know that B sub n plus 1 is equal to B sub n times Q. Let us write a few terms. B sub 1 is equal to B sub 1, and B sub 2 is equal to B sub 1 multiply Q, and B sub 3 is equal to B sub 2 multiply Q is equal to B sub 1 multiply Q is equal to B sub 1 multiply Q squared, and B sub 4 is equal to B sub 3 multiply Q is equal to B sub 1 plus Q squared times multiply Q is equal to B sub 1 multiply Q cube. B sub 5 is equal to B sub 1 plus multiply Q to the 4. B sub n is equal to B sub 1 multiply Q to the power n minus 1. And this is the general term of geometric sequence. Fifth example, Bn B sub n is a geometric sequence with b sub 1 is equal to 1 over 3 and q is equal to 3. Find b sub 4. Solution using the general term formula, b sub n is equal to b sub 1 times q to the power n minus 1. Therefore, b sub 4 is equal to 1 over 3 multiply 3 to the power 4 minus 1 is equal to 9. Sum of the terms of a geometric sequence. Let us consider the geometric sequence with the first few terms. 1, 2, 4, 8, and 16. The sum of the first term of this sequence is obviously 1. And the sum of the first two terms is 3. The sum of the first three terms is 7. And so on. To write this in a more formal way, let us use S sub n to denote the sum of the first n terms. S sub n is equal to b sub 1 plus b sub 2 plus sum of plus b sub n. S sub 1 is equal to S sub 1 and the S sub 2 is equal to 1 plus 2 is equal to 3. S sub 3 is equal to 1 plus 2 plus 4 is equal to 7. And the S sub 4 is equal to 1 plus 2 plus 4 plus 8 is equal to 15. Sixth example, given the geometric sequences with general term b sub n is equal to 3 times minus 2 to the power n. Find the sum of first three terms. Calculating terms and finding their sums takes time and effort for large sums. As geometric sequences grow very fast, we need a more efficient way of calculating these sums. The following theorem meets our needs theorem. We prove this example. Proof. The sum of the first n terms of geometric sequences is S sub n is equal to b sub 1 times 1 minus q to the power n over 1 minus q. And the q is not equal to 1. And S sub n is equal to b sub 1 plus b sub 2 plus b sub 3 plus b sub n minus 1 plus b sub n. Next, S sub n is equal to b sub 1 plus b sub 1 plus q plus b1 times q squared plus b1 times q to the power n minus 2. This first. And the q times S sub n is equal to b sub 1 plus q plus b sub 1 plus q squared times q squared plus b sub 1 times q cubed plus b sub 1 times q to the power n minus 1 plus b sub 1 times q to the power n. And the subtraction 2 from 1, we get s sub n minus q times s sub n is equal to b sub 1 minus b sub 1 times q to the power n. S sub n is equal to b sub 1 times 1 minus q to the power n over 1 minus q. Okay, thank you for your attention. Goodbye.